Okay, so we have the 38th question. I will represent the diagram here. Now here we are using an ideal voltmeter, which doesn't affect the current in the circuit because it has an infinite resistance. Ideal voltmeters have an infinite resistance. If it has an infinite resistance, there's no current movement through it, right? Therefore, on both occasions, when the positive terminal is connected to X and connected to Y, the current through the voltmeter is zero. Therefore, the current in the circuit doesn't change, right? So on both occasions, realize that the current is the same. So don't keep on substituting again and again. The current is the same, right? Yeah. Now here I have what? 40 plus 60, 100 ohms. Here I have what? 100 ohms. 100 ohms and 100 ohms parallel to each other. If 100 ohms and 100 ohms parallel to each other, the equivalent resistance is going to be 50 ohms. The potential difference across that 50 ohms is going to be equal to what? 20 volts. So V equals IR. V is 20, I is unknown, R is 50. 20 divided by 50, 0.4 amperes. 0.5 amperes means what? 400 milliamperes. Don't write anything. This is how we should solve MCQs. So we have what? 400 milliamperes to be the current on both occasions. Be the positive terminal connected to X or Y. What differs is the potential difference. The potential difference or the reading of the voltmeter is what differs. Now listen. It's earthed here. Potential is zero. Then along the same line, potential is zero here as well. Along the same line, potential is zero here as well. Right? So when the key is at X, what can you say? When the key is at X, the positive terminal reads the potential at X. So positive terminal reading minus negative terminal reading gives you the reading of the potentiometer. Voltmeter, I'm sorry. Positive terminal reading minus negative terminal reading gives you the reading of what? The voltmeter. Reading of the positive terminal now, because positive terminal is connected to X, is what? 0. What's the reading of the negative terminal? Can you see the reading of the negative terminal is like this now? 20 volts is divided between 40 and 60, right? So 40 and 60 divide 20. How can you divide? Listen, 20 is there between what? 100 ohms, right? How much across? 60. How much across? 40. So let's say how much across 40? How much is that across 40? It's what? 8 volts. 8 volts across 40. And what? 12 volts across what? 60. Actually, you don't have to do this. You can think, because you're getting ratios. What's the ratio of resistances? 40 is to 60. That means what? 80 is to 120. 80 is to 120 is like what? 8 is to 12. So ratio of resistances is like what? 8 is to 12. Which is the ratio of what? Potential differences. Ratio of resistances R1 is to R2 is equal to what? Ratio of what? Potential differences between them. V1 is to V2. Because the same current is moving. You know, V is equal to IR. Now these are theories that you should not remind actually, because you've done this in classes, right? You've done this. If the current is same across the resistances, can you see potential difference across the resistances is proportional to what? The resistance of the resistances. Is that clear? Yeah. So V1 is to V2, which is 8 is to 12, is equal to what? 40 is to 60. Right? Yeah. Okay. Now listen. What's the potential difference across 60 ohms? Yeah. Let's call this point 1. V1 minus what? 0. No, potential difference is what? V1 minus 0, which is what? 12 volts. Then V1 minus 0 is 12 volts. That means V1 is what? 12 volts. V1 means what? Yeah, potential at the negative terminal. So it's what? 12 volts. And I get minus 12. Is that clear? So I get minus 12. I hope you can understand this. Right. Then the key is at Y. What happens when the key is at Y? Yeah, let's see. Now does the potential here change? Now we found this to be 12 volts. Now don't realize that. You can keep it in your memory because this doesn't change, right? Because Just because you move the terminal from x and y, does the potential here change? No, nothing happens to the potential because the current is the same, right? Okay, now listen, I'm going to move the positive terminal to y. Then the potential at y is going to be what? 20, no? Look at this wire, continuous wire. Continuous wire connects plus 20 volts. Because this is 0, because this is 0, this is plus 20. Potential difference is 20 volts. If this is 20 here, along the same y 20. Therefore, the potential at y is going to be what? 20, right? So we have the positive terminal reading minus negative terminal reading is equal to reading of the voltmeter. Positive terminal reading this time, because it's at y, it's equal to plus 20 minus 12. V negative is 12, doesn't change. Therefore, this is equal to what? 8 volts. I hope you can understand this. Slow the video down. Watch again and again if you can't understand this, right? If you really can't understand this, that's because you have trouble with the theory. Then you should go through the theory slowly, right? Yeah. Now, I can explain these things only if when I consult somebody individually, then I can see, well, did he understand this point from the facial expressions and the ideas? But when I'm explaining this universally, right, to everybody. So I'm making it possible to understand for everybody. But if there is a doubt, please ask me. I'll explain again, right? Yeah. So then what's the answer? Fifth one. Fifth one is the answer, right? Okay. So we have the 39th question now. What about the 39th question? A metal wire of length 2 meters, yeah, and all this data, right? You can read it, right? I'll do the question. Please read the question, right? I'll mark the data. So we have A, 2 points A and B, points A and B, and this is a 2 meter long wire. This is the midpoint of the wire, and you're hanging a weight, therefore it's bent, right? The weight is going to be 24 newtons downwards. 2.4 kilograms means 24 newtons downwards. A tension develops. Tension here. Tension here. Tension here. Right. The angle is like, let's call the angle this one to be theta. This angle to be theta. What can you say? Yeah. T sine theta. 2t sine theta, because t sine theta plus t sine theta upwards, no? T cos theta cancels off. Can you see that? T cos theta cancels off. What remains is what? Upwards 2t sine theta. 2t sine theta is equal to what? 2t sine theta is equal to what? 24 newtons, because that's talking about vertical equilibrium. If we talk about vertical equilibrium, we can say 2t sine theta is equal to what? 24 newtons, right? Then we can say t sine theta is equal to what? 12, right? Now listen, here sine theta can be made approximately equal to what? Tan theta, because this angle is very small. Just think, we have 1 meter here, and this height is like what? 2 centimeters. Then I can say t tan theta is equal to what? 12. Then t is equal to what? 12 over tan theta. Okay, what is the value of tan theta? Tan theta means what? Opposite over what? Adjacent. Adjacent is 1 meter. You can remember it like this. CD all hen, crackles and hackles, till all age. CD all hen means sine theta is equal to what? Opposite over what? Hypotenuse. Crackles and hackles, cos theta is equal to what? Crackles and hackles, therefore adjacent over what? Hypotenuse. Then till all age, tan theta is equal to what? Opposite over what? Adjacent, right? So remember those things. There's some tricks you may forget in the exam time because you're under stress, right? Sometimes you're under stress. Therefore, when you're under stress, you feel like, well, I don't know what tan theta is, like I forgot, right? So then these kind of ideas will help you a lot. Get this? So what's tan theta then? Yeah, the opposite. The angle is theta, right? If this angle is theta, this angle is theta. Opposite of adjacent, what's opposite here? 2 centimeters. Adjacent is what? 100 centimeters. Therefore 2 over what? 100. Then it's like what? 600 newtons. No? Clear? 600 newtons. So tension is 600 newtons. We found the tension to be 600 newtons. Please copy this, or you can take a screenshot. I'm going to erase this part now, right? Okay. Right, look at this. Next point. Tension is known now, right? Now they mentioned the extension of the wire, total wire, the extension of the total wire is what? 0.04 centimeters, which means 4 times 10 to the power minus 4 meters. But then if the extension of the total wire is 4 times 10 to the power minus 4 meters, then extension of this part of the wire is what? 2 times 10 to the power minus 2 minus 4 meters. Half of it, right? So 2 times 10 minus 4 meters is going to be the extension of this segment, half of the segment of the wire. The tension that this part of the wire experiences, half of the wire experiences, is 600 newtons. Now you know this equation. Stress over strain is equal to what? Young's modulus, right? Stress over strain is equal to Young's modulus. E means extension, L means length, F means force, A means cross-section area. What's the stress here? Stress is the tension over what? Cross-section area. What's the tension? Yeah, what's the tension? Tension we found to be 600, right? You can see that this wire experiences 600. What's the cross-section area of the wire? 5 millimeters squared. That means 5 times what? 10 to the minus 6, right? Meter squared, where I put everything in standard units, right? Divided by E. Extension of this segment of the wire, half of the wire, is going to be 2 times 10 to the power minus 4 meters divided by the length L. What's the length here? The length is going to be 1 meter, right? Which is what? Yeah, 1 meter, that's it, right? So let's simplify and see. Then I get 600 divided by 5 times 10 to the minus 6. I can take this down, right? Then I get like this. 6 times 10 to the power 2 divided by what? 5 times 10 to the minus 6 times 2 times what? 10 to the minus 4. This becomes 5 times 2 is 10. Then here I get 10 to the minus 9, right? Because you can see that 10 times 10 to the power minus 10. 10 to the power minus 9. Then 10 to the minus 9 goes up, it becomes 6 times what? 10 to the power 11. That's the answer. The fourth one is the answer, right? Hope you can understand that. Okay. 40th question. An infinitely long, thin straight wire, which is located on the z-axis, has a linear charge density of minus lambda. A small positive charge plus q of mass simple m is allowed to move in the xy plane in a circular path of radius simple r above the wire. The periodic time of the particle, charged particle is, right? Let's see. So I have an infinitely long thin wire which is straight, and this wire is on the z-axis. That means this axis is the z-axis. This is the x-axis, this is the y-axis, z-axis is towards here, right? So I'm thinking this is the z-axis. Who cares, right? That clear? I can think this has to be the z-axis, right? But for now, right, for this question, I'm just thinking this is the z-axis. I'm placing that there. Z-axis has a linear charge density of minus lambda. So what's the charge density here? Minus lambda. So it's negatively charged. Remember that, right? Okay. A small positive charge plus q of mass m is allowed to move in the xy plane. So it's like this. It's moving like this. Actually, like the real idea is this now. If the wire is coming towards me, I can say the wire is here, and then the z-axis, because the y is pointing in the z-axis, then it's going the xy plane, and the z-axis is the way the y is pointing, right? So then it goes along a certain radius r in a circular path, right? Okay. The periodic time of the charged particle is, now let's settle down and listen, right? Okay. First, I'm going to prove the electric field intensity around this infinitely long thin straight wire, right? Let's see. This is negatively charged, so electric field lines are coming towards it. Okay, I'm going to consider a cylindrical portion like this. I'm going to consider the length of the cylinder to be L, and the surface charge density, right, or have they said charge per unit length, right, linear charge density, sorry, so it should be linear charge density. Linear charge density is what? Minus lambda. So what's the total charge within my Gaussian surface? Now this is my Gaussian surface. Gaussian surface. What's the total charge within my Gaussian surface? The total charge within my Gaussian surface is going to be what? The charge per unit length minus lambda times what? The entire length L. That is within my Gaussian surface. So I have minus lambda L. I'm going to consider a point at a distance of r from the straight line wire, right? Straight wire. So I'm going to consider this as point A. So I'm going to find the electric field at point A. Is unknown to me, right? Electric field at point A, which is at distance of r from this line. Okay, so according to the Gaussian surface theory, Gaussian theory, EA epsilon naught is equal to what? Sigma Q. EA epsilon is equal to what? Sigma Q. Epsilon naught is when it's in the vacuum. So generally it's epsilon, right? So EA epsilon is equal to what? Sigma Q. But in this question they've just mentioned epsilon naught. Right, so EA epsilon naught is equal to what? Sigma Q. Sigma Q means total charge within my Gaussian surface. The total charge that is within my Gaussian surface. What's my Gaussian surface now? The cylindrical Gaussian surface. It's a cylinder having this radius r here, right? Why did I consider radius r here? Why is that? Because I have to find the electric field intensity at A. So electric field intensity at A is equal to what? Sigma Q over what? A epsilon naught. What is sigma Q? Now let me know what sigma Q. Total charge within my Gaussian surface is what? Minus lambda L. Because minus lambda is the surface, is the linear charge density. Minus lambda is the charge that I can find in a unit length. Then the charge that I can find in length of L is going to be what? Minus lambda L. Is that clear? Right. Divided by area A. That is the area of my Gaussian surface through which these electric field lines are cutting through. What's the area of my Gaussian surface? Yeah, 2 pi r L. 2 pi r L. Okay. Then times epsilon naught. Can you see L and N cancels off? So you can see electric field intensity at A is equal to what? Minus lambda divided by what? 2 pi r epsilon naught. Let's remember this now, and I'm going to erase this so you can take a screenshot and better, right? Like we've been used to be very lazy these days, right? Right. So when you watch a lecture, we just take a screenshot and we become lazy. But it's better to note down in your books because you feel and write it, right? Yeah. Okay. So let's see the question now. So we found the electric field intensity. So I'm drawing the wire like this. It's in the z-axis, right? It's coming out. So the radius of the path, the charge, is it positive charge? Yeah, it's positive charge. Definitely, otherwise it can't go. So positive charge is attracted to what? This negatively charged straight line wire. So the radius is r. The force is F, which is acting towards what? The straight line y, because you saw that this straight line y negative negative was there, negatively charged. electric field lines were like so. Therefore, the positive charge is attracted to what? The straight line vibe. But it has a velocity v. If it has velocity v and the force of attraction F, if they're perpendicular to each other, the force cannot do work. Because force and velocity, they're perpendicular to each other. Therefore, what happens is, it goes in a circular path like this, right? If it has a velocity v, and if its mass is m, I can say what? Centripetal force is equal to what? mv squared over r. That should be equal to what? The electric force exerted. Now, F is equal to what? Electric field intensity at that point A. Remember the point A? Electric field intensity at point A times my charge Q. Electric field intensity at point A times my charge Q gives you what? The force that's experienced by the mass M having a charge plus Q. And I can say this is equal to what? EAQ. But in the question, they're asking for the time period, I guess, right? So they're asking for the time period. Therefore, we cannot use this equation, mv squared over r. We can use what? M r omega squared, which is equal to what? Omega means 2 phi over t. Then mr omega squared means what? M r 4 phi squared over t squared. Because 2 phi over t entirely squared means omega squared. Then 4 phi squared over t squared. Then I get m times what? R 4 phi squared over t squared is equal to what? Electric field intensity at A times charge Q. Now let's see this. So what should I find? Time period is equal to what? mr 4 phi squared divided by what? EAQ squared. I'm not going to put the square root now itself because we have to substitute EA. What's EA equal to? So mr 4 phi squared. What's EA equal to? Yeah, minus lambda. Let's see. Give me a second, right? There's something wrong. You got what? mr 4 phi squared over t squared. That's equal to what? EAQ. Yeah, so far correct. Yeah, correct, right? So we got this. Then I can write it like this. mr 4 phi squared over t squared is equal to what? EA is minus lambda 2 phi r epsilon naught times q. Then I get t squared is equal to what? 2 phi r epsilon naught times this term divided by minus lambda q. Then I get what? I get this answer. 8 phi cube r squared m epsilon naught divided by lambda q. I'm not going to change the minus charge because this has no meaning here, right? So t is equal to what? Square root of this. The answer is the first one, because you don't need the minus charge because you've already mentioned directions, right? mv squared over r is EAQ. So don't substitute the minus charge. It's unnecessary. So the answer is the first one, right?